Hi, hello dear students. Welcome to my first lesson, first session of iGCSE chemistry. In this principles of chemistry session 1, I will take and that principles of chemistry first I will take the states of matter. Now, to understand the arrangement and movement and energy of particles of each of three states of matter, then solids, liquids, and gases. The another important content I will discuss is describe how the interconversion of solids, liquids, gases are achieved. And recall the names of these interconversions. I will teach. Another important content in this one is describe the changes in the arrangements and movements of energy particles during these interconversions. Okay. Now let us see. What is the difference? What is the difference of all the three states of matter here in terms of shape? Can you pour, can you stir, can you squash? And the solids, if you take solids, can be having fixed shape, but you cannot pour, you cannot stir, you cannot squash. Whereas if you take the liquids cases, liquids can be changed. That means the shape can be changed. Can you pour? Yes, you can pour it. Can you stir? Yes, you can stir it. Can you squash? You can squash it. They are liquids. What about gases? They don't have any kind of shape. Can you pour? Yes, you can. Is a question. Can you stir? Yes. How? Can you squash? Yes. So, this is the difference among the solids, liquids, and gases. Changes of state. A gas can be converted into a liquid, liquid can be converted into solid. Suppose a solid can be converted into liquid, that phenomenon is called as melting. When a liquid is converted into gas, that phenomenon is called as boiling or evaporating, right? When a gas is converting into liquid, that is called as condensing. When a liquid is converting into solid, that is called as freezing. Okay, these are the changes. So these are the fundamentals of the changes taken place between the states of matter. In another way, if a solid is there, solid is said to be a state of matter, particles are fixed in space and cannot move. What about liquids? Liquids particles are free to move within container. What about gases? Gases particles are free to move about. What is the solids? Strong forces of attraction are exist in solids between the particles. Held fixed position. So lattice arrangement is there. They don't move, so they have definite shape and volume, but they'll vibrate. As they become hotter, the particles vibrate more, so they expand, they cannot be compressed. Solids generally very dense. Solids, when heated, molecules gain energy. They vibrate more and more. Their strong forces overcome, molecules start to move, they are melting. Let us see the liquid cases. This is the arrangement. Some attraction between the molecules is there, but free to move. No definite shape, but take the shape of the container. Molecules in constantly random motion. Liquids, when heated, they move faster and expand. They can be compressed, quite dense there. And in the case, the liquids, if you heat, they make molecules move faster and they gain energy. The fast moving molecules at the surface will overcome forces of attraction or escape, that is called as evaporation. Gases, If you see, this is the arrangement here, the arrow marks and all, the no force of attraction between them. So free to move and travel in straight lines. Sometimes they collide, no definite shape or volume expand to fill space. Gases exerts pressure on wall of container and constantly moving randomly. They move faster when heated, can be compressed and very low densities. Gases when heated, enough molecules have enough speed and the energy to overcome forces and escape each other. Molecules break away in big bubbles of gas that is called as boiling. Right. Now you'll see the heating phenomena. When you solids heated, with the time they'll slowly melt according to this discussion. Liquids converted into gases, the phenomenon is called as boiling point. When a gas is converted to liquid, is called as condensation. The liquid is converted into solid, is called as freezing. Okay. This is what the first content. So in this content, what we learned here is content 1. We have learned about arrangement of movement, energy of particles, and second content also we finished, that is describing how the interconversion of solids and the liquids and gases achieved. They recall the names of these interconversions. So moving on to the another content we discussed, that is describe the changes in arrangements, moment and energy of particles during these interconversions. That's what we saw in the first point. That is the second content, that is atoms. First content we discussed, that is traces of matter. Second content is content in the atoms is describing some simple experiments leading to the idea of small size particles and their movement, including dilution of colored solutions and diffusion experiments. Another content we will see in this one is understanding the terms atom and molecule, and also understanding the difference between the elements and the compounds and mixers, and describe the techniques and separation of mixers, including simple distillation, fractional distillation, filtration, crystallization, and paper chromatography. Also the evidence of the particles. Here particles are very, very small, but evidence do we have there actually exists is two simple experiments are there: dilution of colored solutions and diffusion experiments. First, if you see, this is the dilution of colored solutions. Here we have blue copper sulfate solution is there. Here in this is the blue colored solution, and dilution 10 centimeter cube of copper sulfate solution and 90 centimeter cube of water is taken here. The color, if you observe here, when water added, then the intensity of the solution color changes. And finally, what happened here? Serial solution of solutions such as copper sulfate solution provides evidence that original crystal was made up of many small particles that spread out evenly when the solution is diluted by adding water. Evidence of particles diffusion experiment, if you see spray air freshener in the corner of the room, then what is the phenomenon? Is that the particles spread all over the directions here is shown, right? That is one experiment. Another one diffusion experiment, if you see eventually what happens, the particles occupy the whole room finally. Another examples of diffusion is smell of frying bacon from kitchen, leaking of air from inside a balloon, sugar dissolving in a cup of tea. So all comes under this category. And moreover, you know that gas leaking also is an example for this one from cylinder. Another diffusion experiment, diffusion is nothing but definition, there is movement of particles from areas of high concentration to areas of low concentration until they are evenly spread. The diffusion depends upon the random movement of particles, right? So diffusion is slower in liquids than gases because liquid particles are not as free to move as gas particles. The next one, atoms and molecules. So now we get an information that atoms and molecules existed from the previous experiments. The basic building blocks of everything that were seen universe are atoms. The word atom basically means indivisible. That is the meaning of it. So combination of atoms are called as molecules. For example, oxygen is a molecule of oxygen, here O2. H2 is a molecule of water. Now elements, mixtures and compounds, will see elements, here copper is there, here symbols. An element consists of one type of atoms only. For example, pure copper consists of copper atoms only. And you see here sulfur, iron, all this mixture is there. A mixture consists of different types of atoms that are not chemically bonded. So particles in a mixture can all be separated out quite easily. No chemical bonds exist, so you can easily separate. And properties of mixture are just mixture of properties of separate parts. Elements and mixture of compounds, here FES, CO2. In a compound, particles are held together by strong forces called chemical bonds. So a chemical reaction will have taken place. So what the points in this one is, particles in a compound very difficult to separate, and the properties of compounds are very different to that properties of original elements. You need to be able to describe the techniques for separating mixtures, in that filtration, simple distillation, fractional distillation, crystallization, pepper chromatography. This is the first one, filtration. See, filtration depends upon the size of different particles of the mixtures. Filtrate passes through the filter, pepper or residue is left behind. So this is the residue. The technique is used to separate an insoluble solid from liquid, that is sand and water. Sand and water is an example here. Simple distillation, the next one is simple distillation. If you see here, this is simple distillation. Upon the different boiling points in a mixture, the lowest boiling point evaporates first and that can be collected. The technique is used to separate the soluble solid and liquid. Example, pure water from salty water. What about the fractional distillation? Fractional distillation is used to separate the two separate liquids that have different boiling points. Here different boiling points are there. The technique is used to separate mixtures such as ethanol and water can be separated by using fractional distillation. Moving on, the next one is the crystallization, where crystallization is used to separate the soluble solid from liquid when we want to collect the solid. So this technique is used to separate mixtures such as salt and water when the salt is required. Okay, crystallization, you will use that one. Next one. What about paper chromatography? You see the distance traveled by the red pigment here, you observe here 8.2 centimeters is experimentally given here. There is a start line here. Chromatography is used to separate, identify mixtures that are or can be colored. Okay, that means the technique is used to separate the mixtures such as pigments in an ink sample, that is paper chromatography. Next chapter, next lesson, that is atomic structure. In this lesson 1 we have, that is, and is the contents we'll see this recalling the atoms consist of central nucleus composed of protons, neutrons, surrounded by electrons orbiting in cells. Another content will see the recalling the relative mass and relative charge of the proton, neutron and electron. The content, the other one is that understanding the atoms, atomic number, mass number, isotopes and relative atomic masses. Another one, calculating the relative atomic mass of the element from the relative abundances of its isotopes. The another one, understand that the periodic table and arrangement of elements in order of atomic number. The other one, deducing the electronic configurations of the first 20 elements of their positions in the periodic table. The next one is deduce the number of outer electrons in a main group element from its position in the periodic table. So these are the main things in this discussion. We will see the first one, size of an atom. Here size of an atom, if you observe here, this is the head of the pin. Head pin is the milestone of atoms would fit into it. So millions of atoms will fit into this one here. This is called size of the atom. A spoonful of sugar here, if you shown spoonful of sugar will contain about a big number of atoms. So atoms are very, very small. So an atom is the smallest particle of element that can exist. So cut a diamond up with a magic knife until you have smallest piece possible and you have a carbon atom. So diamond is giving carbon. This is a block of gold here we are observing here. They begin with an element and it is a pure substance, so it contains particles of only one kind, that is gold. So these are gold atoms. The next one is, if you see it atom general picture here in this is the nucleus. And this is the middle of the atom. It is there. It contains protons, neutrons. It has positive charge, protons and positive charge is there. Almost all the atom mass is concentrated in this nucleus. Tiny compared to the atom of as whole. That means when compared to the atom size, nucleus size is very, very small. Next one, these are the electrons which are present in the shells here. We are observing here. These are the electrons. So electrons move around the nucleus. They are negatively charged. It's a tiny, and but they have a lot of space orbit. Volume determines the size of the atom. Virtually no mass is there for this one, or occupy orbits and shells around the nucleus. Facts about the atoms, we check it in this first one. The neutral atoms have no charge overall. Charge on the electrons is the same size as the charge on the protons, but opposite. The other one is, in a neutral atom, the number of electrons equal to the number of protons. Electrons may be lost or gained. The atom then becomes charged and is known as ion. Neutral numbers are usually just a bit higher than proton numbers, but can change. So neutron numbers are usually just a bit higher than proton numbers, but can change. Let us see facts about the atom in this: particle, proton, neutron, electron. You see, mass of the proton is 1, charge is +1. Neutron is mass is 1, charge is 0. Electron mass is approximately 1 by 2000, charge is -1. Atomic mass and mass number. You see, this is the symbol of sodium. Symbol of sodium is Na, and it's 11, 23. This 23 is the mass number. Total number of protons and neutrons. When you see 11, 11 is the atomic number. This is the number of protons, also called as or electrons, when it is neutral. So the number of neutrons can be obtained by subtracting the atomic number from mass number. So mass number is always bigger than atomic number. Remember, mass number is always bigger than atomic number. Next, for sodium, how can you find this proton number? Here the symbol is 11. 11 is the number, is nothing but it is proton number, and electrons number is 1, neutron number is 12. How came 23 minus 11? Next one, what is an isotope? Isotopes are the different atomic forms of the same element having the same number of protons but different number of neutrons. For example, there are two common forms of carbon are there. Here we have, that is proton, neutron, electron. Here these are the carbon 12. If you see, proton number is 6, neutron number is 6, electron number is 6 in carbon 12. Carbon 14, if you observe, proton 6, neutron 8, electron 6. So chemical properties of these are same but different number of neutrons. A nucleus does not affect the chemical behavior at all. So nucleus is not involved in the chemical behavior. What are the relative atomic masses? By definition, the mass of proton atom compared to the mass of atom of hydrogen. Relative atomic mass is also same as the number of mass number. Is that simple? So why do some atoms have odd looking relative atomic masses like 35.5 on all these things? So why has chlorine has got relative atomic mass number 35.5? So this is the question here. See, what is relative atomic mass number? That is because the chlorine has two common isotopes are there. We have 35 is there, 37 is there. In this, they are found neutrally, naturally in the ratio 3:1. So the average relative atomic mass can be obtained like this: 35 plus 35 plus 35 plus 37 by 4, 35.5. So chlorine is written as 35.5. Where do we find the relative atomic mass and atomic number of an element, and so calculate the number of protons, neutrons, and electrons in an atom? We look in the periodic table here. This is our periodic table. So in this periodic table, vertical columns are called groups, and number from 1 to 8 here. See, and it's 1, 2, 3, 4, 5, 6, 7, 8. See, these are the vertical columns. These are groups. Moving on next one, horizontal rows. What are horizontal rows? They are periods. Number 1 to 7, they are periods. Here, 1, 2, 3, 4, 5, 6 are the periods. So for any given element, we can read off the group and period number. For example, silicon, if you take group 4, period 3. That is. Also, for any given element, we can record the atomic number and relative atomic mass. For example, you take beryllium, it's 4 atomic number. Its relative atomic mass number is 9.0122. So let's just pause and recap second. You should know how to find out for any given element. Relative atomic mass number, atomic number, neutron, proton number, electron numbers. Are you ready for some practice? Yes. See, these are the elements here. For example, hydrogen, if you take, atomic number is 1. Symbol is H. Atomic mass number is 1. Number of proton is 1. Number of neutrons is 0. Number of electrons is 1. Likewise, lithium, you have 3 is the atomic number. Proton number is 3. Electron number is 3. Potassium, symbol is K. Atomic number 19 from the table. Atomic mass number is 39. And electron number is 19. Beryllium, we have B is the symbol. And 4 is the atomic number. Relative atomic mass is 9. Number of protons is 4. Cesium, calcium, if you take, relative atomic mass is 40. Neutron number is 20. Electron number is 20. Iron, symbol is Fe. Atomic number is 26. Number of protons is 26. Number of electrons is 26. Boron number symbol is B. Atomic number is 5. Atomic mass number is 11. Proton number is 5. Neon relative atomic mass is 20. While that of number of neutrons is 10 and electrons is 10. So this is from the periodic table we collected. Note, the periodic table is arranged in order of increasing atomic number, not the mass number. So do you remember the electrons are found in orbits or shells around the nucleus? Yes. The orbits can only hold a certain number of electrons. That is also most important. The first orbit hold 2 electrons, second orbit, second and third will hold maximum 8 electrons. Let's look at some examples here. Lithium is there. So number of electrons is 3 here. The first 2 electrons go to the first orbit and the remaining electrons go into the second orbit, right? So that is regarding lithium, and electronic configuration will become, the electronic configuration will be written as 2, 1. For silicon, if you take silicon, atomic mass number is 28 and proton number is 14. So 14 is the electron number. The first 2 electrons goes into the first orbit, and next 8 in the second orbit, next 4 in the third orbit. So 284 is the electronic configuration. To make sure you understand this, try drawing the electronic configurations, then you'll get the first 20 electrons hydrogen to calcium. Next. In the periodic table, actually LG help us when we have trying to work out the electron configuration of particular element. In periodic table, the group number tells us how many electrons are there in the outer shell of an element. For example, oxygen is a group 6, so has 6 electrons in outermost shell 2, 6. In periodic table tells us how many shells here they are around the nucleus. For example, calcium, the period number is 4, so we will have 4 shells around the nucleus of calcium. So this is what 2, 8, 8, 2 is the configuration. So this is the end of this lesson. We discussed states of matter, atoms, and structures in this lesson. So dear students, we have discussed about the major portion of this lesson 1 of iGCSE syllabus, and I hope you understand this presentation explanation. You can again and again you can recap that things what I have discussed in this lecture. This is the lesson 1. I will come with the lesson 2 in the next lecture. Until, have a nice day. Keep watching my channel, Race Chemistry, Race Academy, Bangalore. Thank you very much.